Team, it's Mr. Z, and today we're going to review how to reduce fractions by dividing by the GCF. Let's go ahead and dive on in. So we got to think about the difference between factors and multiples. So basically, side by side, we got to figure out, hey, the factors of 18 are, well, factors are math facts. Factors are always going to be smaller. So I usually represent it in this course with 18. And then you got to ask yourself, what numbers multiply together to be 18? 1 times itself will always be the first factor pair. The reason being is 1 times 18 has a product of 18. Now, it would go in order. The next factor, so in the list, I go on the left column, is going to be 2. 2 times what is 18? Well, you can ask yourself, what is 10 plus 8 divided by 2? That's 18, right? Half of 10 is 5. Half of 8 is 4. Half of 18 is 5 plus 4, which is 9. All right, something happened between line 1 and line 2. Notice here, between the numbers 1 and 18, there are multiple. There could be 2, 3, 4, so on and so forth. And then it would go up to 17 and 18. Our responsibility would to be check between all of these numbers. But now in the second line, I would have to just look at the numbers between 2 and 9, which would be 3, 4, 5, 6, 7, and 8. That's my responsibility to check all of those. But going in order, I find out 3 is a factor of 18. And the reason for that is 3 times 6 is 18. What happens is, instead of having to look at all of them, now I just have to check the region between 3 and 6. That means, is 4 a factor? Is 5 a factor? And both of those are not. When you divide 18 by 4, you're going to have a remainder. 4 goes into 18 4 times. You minus 16, and you have a remainder of 2. 4 is not a factor. It has a remainder. Likewise, 5 is a factor, or is not a factor for the same reason. 5 goes into 18 3 times. My answer would be 3 and 3/5. Remember, all around the world, go clockwise. So, my list is done. The next number would be 6 and then 3. This would be a repeat, and it's not necessary for my list. But whenever I need to write out the factors, I have to list all of the factor pairs. I have to be comprehensive. To review multiples, you have to remember multiples is a sequence. It's always going to look like 18 comma something, something, so on and so forth. I need to figure out the first 5. Well, you can use repeated addition. And I can do it again, but I'm going to add 18 this time. Or I can do 18 times the 4th term. 4 times 8 is 32. 4 times 1 is 4. 72. And if you want to use the method I was showing off, 18 times 5, I would actually represent it as a different problem. I would represent it in an expanded form. I'm going to do 10 and 8. 10 plus 8 is 18. 5 times 10 is 50. 5 times 8 is 40. So put those together, and you get 90. All right, what's the difference between the size of the factors in 18 and the size of the multiples? Factors will be smaller or equal to the original number. Multiples will be bigger. So we're going to go ahead and review how to calculate the product of a fraction, and we're going to reduce it in one step by dividing by the GCF. So go ahead, multiply the numerators together. In this problem, 3 times 5 is going to be 15. 4 times 10 is going to be 40. Now, I'm going to go ahead and list out the factors of both, and I'm going to leave some space in the middle. Writing my lists out, I always start out with 1 and 15 and 1 and 40. So, my next check is to do 2. Well, 15 is not even, so 2 is not going to work out. I am going to try 2 for 40. What's half of 4? 2 with a 0. Okay, next up on the list to check, 3. Does 3 go into 15? I could either do long division or look at the multiples, and it would be 3 times 5. However, 3 does not go into 40. The reason being, if I wanted to show some work on the side, 40, 3 goes into 4 one time, bring down the 0, 3 goes into 10 3 times. Notice how there's a remainder. That is why it is not a factor. Okay, looking at this list right now, we've checked 1, 2, and 3, and we're going in order. I hope you can see for the list of factors, I have to check the numbers between 3 and 5. Well, that's only 4, and 4 does not go into 15 evenly. 4 does go into 40. Well, 4 what goes into 40? 4 $10 bills. So I want you to know at this point with 15 we're done, because if I were to continue my list, it would be 5 and 3. Notice how this communicates the same information as above. So I don't need to omit it, but I'm done. My responsibilities are over. However, for 40, I am still responsible for checking the numbers between 4 and 10. That's going to be 5, 6, 7, 8, 9, and so on. So I'm going to check 5. 40 ends in a 0, so I know it's divisible. How many times does 5 go into 40? Well, if 4 $10 bills go into 40, 8 $5 bills. Basically, you need double the amount of $10 bills to get in. Now notice what happened. My list got shorter. Here, I needed to check 5, 6, 7, 8, 9. My list is shorter now. I'm only responsible for checking 6 and 7, which both do not work. Now at this point, I'm done. I've done all of the work, and now it's just a matter of resolving it. I draw my Venn diagram, and I'm going to write all of my common factors. So let's see. They have 1 in common. They have 5 in common. 1 and 5 are what's known as common factors. They're the factors that both of these numbers share. What is going to be the GCF? It's going to be 5. So watch what happens. 15 over 40. I need to divide it by the GCF. So what is the GCF? Well, 5. I divide the numerator and the denominator. Watch what happens. 15 divided by 5 is going to be 3. 40 divided by 5 is going to be 8. So, without using a calculator or anything, I'm just looking at my t-chart. I get the fraction 3/8. 3 is a odd number, and because 3 only has 2 factors, it's going to be also prime. 8 is even. Why? Well, 2 is a factor, and it has more than 2 factors. So 8 is going to be even composite. You want to think of it as each factor has 2 names, a even, odd, prime, and composite. So all these can be done the same way. The idea is that you build your knowledge by writing out these factors lists. The idea is that you're instilling long-term memory. You should be able to recognize some of the common math facts, aka factors. Hope this helped, team.